Hello guys, this is Asmit Goel. In this video, I'm going to explain you the assignment in the Skyfi Labs that was given as a part of the course, Structural Foundation and Analysis. So as you can see on the screen, the assignment question is shown. So we are asked to produce these four sections for the story 1 to 8, 9 to 14, 15 to 19, and 20 to 23. So in this we have to define different sections for different stories in 23 story building. So let's move on to the software and let's see how this building is built. So we are going to use ETAP software which has been taught in the course. So as you can see, the 23 story building is being made in the software. Firstly, for the steps, we have defined the grids and the stories. So 23 stories has been defined, and for the grids, as you can see, we have defined 4 into 4 grid for 6 meter distance. So we have made a few stories as master stories. The purpose of making them master stories is to apply a similar set of properties to a set of stories. So as you can see, story 8, story 14 and story 20 has been made as a master story. After defining a grid, we have drawn the columns, beams and slabs. So as you can see on the plan in story 1, we have defined the beam, column and slab. Before drawing these, we have defined the materials which are going to use in this building. So we are using M40 grade concrete, HYSD 500 rebar steel and mild 250 steel. After defining these materials, we have also defined the section properties, that is frame section. So the frame sections has been defined as beams and columns. 3 beams and 3 columns has been defined, and an auto select column and an auto select beam is also defined. The purpose of defining this auto select beam and column is to select the suitable beam and column according to the requirement. After defining the frame sections, we have defined the slab sections. In the slab sections, as you can see, slab 150 is the name of the slab we have defined. It is of 150 mm thickness and of concrete M40. So after defining all these things, we have applied the loads, and different sections have been made for different plans. Since according to the question, we have to provide different sections for different stories. So this is an example of story 23. We have defined this small section at the top level. So after defining this and drawing the structure of the building, we have defined the loads and the combination. So for the live load, we have put a live load and dead load over the building, and the wind coefficient. According to the wind coefficient, we have applied the wind load. So I'll show you the wind load which we have applied. Coefficient. So the wind pressure of minus 0.8 in the leeward direction has been applied, and for the windward direction, a coefficient of 0.8 is applied. This is according to the IS code IS 187 and 2015. So the area has been chosen as Bangalore for the area. As you can see, the wind load has been applied here. After applying the wind load, jet load, and live load, we went for the analysis of the building. So let's run the analysis. So the system will take some time to run the analysis of the building. As you can see in the tab below, the analysis is in progress. You can see the analysis result in the 3D tab. Once the analysis is finished, you'll observe that the building will start to deform. As you can see, the different displacement of the different parts of the building is being shown. As we hover over the part, we can see the displacement in different directions. After After running the analysis, we can go to the design. In the design, we will check the preference which we have set. The design code we are using IS 456-2000, which is for the concrete sections. So that is okay. Let's press OK and go to the design, concrete frame sections, and start design. The design check will start, and as you can see, the red part is moving over and checking whether the section is passed or not. So the design is complete, and as you can see, there is no notification or any member failing. So initially we have done the iteration, which is for the sections. If any section fails, so we can change the section and it will show how many section fails, and we can select those sections and change the properties for that. With the help of the auto select list, which we have defined earlier, we can change the section of the failing part. So the longitudinal reinforcement details is shown in the 3D tab. If we zoom in, we can see the different properties that has been designed. So the design part is done. To check whether the any member of the structure is failing, we can check that all the members passed or not. So with the help of this option here, verify all members passed, we can check if all the members passed. So it shows all concrete frames pass the design check, and hence the software is ready. We have produced the proper building. Extrude view. Okay, so we are currently viewing the longitudinal reinforced section. So if we made it to undeformed shape, the deformed instead of deformed shape, so you can see the extrude shape, it will look better. So yes, we have designed a building according to the IS 456, and our building is ready. Thank you.